Thanks for joining. Today is day number 16, and today we are going to learn about these topics you can see here below. Differentiate hardware software switching mechanism, CEF, TCAM, MAC address, FiB versus RIB. These topics we try to understand how it is working. So let's get started. Now, different type of hardwares that we have. Cisco, what Cisco is doing, Cisco is a good company related to hardware. They are making chips, or they are utilizing the chips. So what Cisco is doing, that they are in the market, they are in the business where they are creating very good hardware, and those hardware they are doing some sort of programmability. So those hardware, so you can see this particular switch here, and this is switch in a stack, or maybe this is one of the modular chassis. This is 9300. So if you can see here 1 2 3 4, that means this is 93004. It means you have 3 line cards here. Now if you see such type of architecture, you will find that 2 concepts are there. So when we'll go and check Cisco design, and when we are talking about switches and the chassis and the hardware, so at that time you will see that we have 2 different type of designs. So if we have one big switch, in this switch, further if you go and see, this is divided into different line cards. So this is divided into different line cards. And in these line cards, what you will see, that few of the line card will be controller line card. Controller line card means that where you have supervisor engine. So in this, you have normal line cards. Suppose this is line card number 1. Then you have line card number 2. Then you have supervisor engines. Suppose supervisor engine 1. Then suppose you have supervisor engine 2. And then further you have line card. Line card number 3, 4, 5, 6. Now, if you see such type of switch, so you can go and mark out that how many line cards you have, including supervisor engine. So this is line card number 1. Then you can see line card number 2. Then you can see line card number 3. Then you can see line card number 4. This is one of the example, and this is line card number 5. Now suppose this is a series of 9000 series switch. That means the model will be 9505. If it is this, if this switch is 65,000 series, 6505 means the last digit that you are seeing here is the number of line card, and then these are the model number, right? Like that.
Okay.
Cisco is creating their line cards, means this modular chassis switches and all. Okay. Now within this particular line card, we go and see that this is my line card, and okay, I need to make one curve here. Just a second. So this line card that you are seeing here, in this line card, you can clearly see that you will go and this line card may be in the distribution layer, maybe in the core layer, because generally in access layer we are not connecting the line card plus soup engine. So in access layer, you may have 3000 series switch, or you may have normal single line card switch, etc. Your name is also coming here. If you want, you can log out.
Oh no, it's okay.
It's okay. All right, so let me move this here. And increase the-
Oh, okay. Let me.
Okay, no problem. So what I'm telling here is this, that yeah, you can
Oh,
move
okay.
somewhere out. Okay.
Yeah, I
So
was trying to move out. Yeah.
yeah, it's gone. So the point here is this, that okay, the hardware innovation is there, but what's the use of line card? What line card is doing and what supervisor engine is doing? So line card, when we have line card, they are doing the data forwarding. And the soup engine that we have, they are actually there to make the decision. To make the decision. Decision, something. That means that the line card that we have, right, these line card, they are working as a, if you think SDN control, so they are working as a data plane. And since they have to take the decision, so they are working as a control plane. Okay, so that's the thing here, that in this switches, what does it mean? It means that suppose you have some PC. So let me go and connect the PC to the line card. You will understand that. So let me go and take some PC. If I have PC icon, router is there, switch is there, email is there, VH model, network, cloud. So okay, I'll take the server here. So suppose you have server. Think like this, that you have the connection. Your server is connected to one of the line card, and the other server is connected to other line card. Okay, and think like this, that in between, this is working as a layer 3 switch as well, right? So I will do one thing to make this little bit real. I will do one thing. Suppose we have one more switch in between.
I can actually. I don't. Anyway. Okay. Okay. No, I know why I don't see it now.
You're not seeing the screen?
No. No. I need to. Okay, I need to reduce it. Oh no.
You're unable to see my
Okay.
screen?
And I'm able to see it though, but it's just on the corner. But it's okay. That's fine.
Okay.
No. I'm looking at it from my own screen. That's why I'm able to see it from from the Zoom screen.
Yeah, you can log out. Later on, you can log in.
Okay, let me do that. Uh, how do I log out? Oh. Anyway, I'll just close it out.
Yeah, now it's gone.
Mhm.
So what I will do here, that I'll go and you think like this, that we have such type of connection here. Oops. And then we have the connection like this. So in this diagram, you can see that one server is connected like this, and then we have client. So if you see in the real time, the traffic flow will be like this, that it's like line card to line card. The traffic flow will be that this server MAC address will be learned by first switch in the line card. The programming will happen, and then from that line card, from this layer 3 switch, from that line card, the switch will go and build their routing table, because that line card MAC address somehow the routing table should know. So this switch should know how to route to this switch if they are working as a layer 3. Suppose if this server is in different subnet. So suppose this server having subnet 10.1.1. Suppose it has IP this 10.1.100, and this client having IP, for example, 20.1.1.100. So in this case, we are in different subnets. That means routing will happen, right? Now routing will also happen. Plus, first of all, the switch has to go and learn the MAC address.
MAC
So
address. Yeah.
yeah.
Okay.
So somehow this MAC address will be learned by the switch. So switch will go and learn the MAC address. So switch means this line card should learn the MAC address. Once the line card will learn the MAC address, line card is the data plane device. So it should go and inform that MAC address to the supervisor engine, whoever is the active one. Suppose this is the active supervisor engine. So supervisor engine will go and learn that MAC address. But since in this case, what we are doing, that we are building the routing table. So that means that supervisor engine will learn the MAC address, and then it will build the routing table how 10.1.1.0 will go and reach to 20.1.1.0. So supervisor engine learning the MAC from the line card, and then its primary job is to build the routing table how to reach 20.1.100, right? Now, once you know that how to reach, so what it will do, that from this information, it will go and send that information to the next switch control plane, which is the supervisor engine, here, right? So that means that this particular supervisor engine that we have now, he has the information. So this sup has the info about 10.1.1.0. Okay. Now here you will see, because we are dealing with multi-layer switches and multi-line card and supervisor engines and all, what will happen, that internally this information will be bypassed. Oh, so not here. Let me go and so internally what will happen, that this information will get bypassed to this line card. This line card should know, right, that how to reach to the client, and from this line card the query will go and reach to this particular client, where this line card, what this line card is doing, this line card has the MAC address of the client. Okay, and this line card having the MAC address of the server. So the communication that you are seeing here is not like very straightforward. It has multiple folds. So multiple folds means that You can see this will be point number 1. This is first thing that is happening here, or activity number 1. Let me reduce the size there. This is first thing happening, that line card is learning the MAC address, right? Once line card is learning the MAC address, then what is happening? That supervisor engine is building the learning the MAC address and building the routing table, how to reach it, because they are running some static route, OSP, any IGP. Then what is the third thing is happening here? Third thing is this, that they are forwarding that information. So from soup engine to other soup engine, they are building the routing table. Now at the same time, when client is connected to the line card, the other switch is learning the MAC address of the line card, right? And then the communication is happening. So first time, only first time, when the server has to reach the client, the first time the flow will be that it will go via the, so this will go to the line card, to the supervisor engine, to the other side supervisor engine, to the other side line card, and it will reach to the client. This is the first time flow. But once the supervisor engine knows that, okay, line card to line card forwarding is happening, then supervisor engine are intelligent enough that what they will do, they will simply program the line card to reach from, to do the communication from line card to line card. So what I am telling here is this, that they will go and program. Supervisor engine will go. That is one of the duty of supervisor engine, that it will go and program the line card, that you take your own routing decision, something called programming within the hardware. So now line card knows that what's the routing forwarding engine, but line card will go and program the, sorry, the supervisor engine will go and program the line card, that how to do the line card to line card communication. So what I am telling, that the second time flow will be, this is for first few packets, but next time when communication will happen, then it will be like this. Number 1, and number 2.
So this
One
is
and
MAC address table that they are building up, right?
yeah, I will tell you that what these tables belongs to. So I'll come to this diagram one
Okay.
more time. But you understood the flow and all, right? Next time it will be like line card to line card communication, because then supervisor engine will go and teach the line card that how to forward the traffic. Okay, all right. Let's go back to the slide. So now if you see the line cards and all these soup engines and all, everything you'll understand. If we have the SFP based switches and all, then they have very high throughput. Actually, what is happening, these interfaces where we are connecting the switches or routers, behind the scene, they have very powerful ASIC engine.
Mhm,
And within that ASIC engine, all the programming happening. Sometimes you have 4 interfaces mapped with one ASIC. So you can see 4 into 1 gig SFP. Sometimes 8 SFP mapped to one ASIC. Sometimes only 2 interface mapped to ASIC. Sometimes one ASIC is mapped to one port. Like that we have. Now you can see the line card and the supervisor engine arrangement. and you have centralized control, distributed data plane, stateful failover. This is actually a stack,
What's the AS? What's A and S?
active standard. This is actually
Okay.
a stack of 1, 2, 3, 4, 5, 6, 7, 8 members. In that, the first member is the active, rest are the standby. Active means this is active control plane, and rest are only the data forwarding interfaces. Then everything moved to this Catalyst. So now Cisco is selling their new switch, Catalyst switch, having better throughput, programmability, manageability, and all. So it's just the hardware information. I have created some slides for your
Just a quick
reference.
one though. Before you just go back to that diagram that you did, I wanted to ask a question about the data plane and the control plane.
That diagram that I
No, no.
have drawn,
Yes, sir.
I'll come to that.
Okay.
Okay, so a few slides are there just for your reference. Just have a look on this, the mapping with the ASIC and the interfaces. New ASICs. Now this is a little bit older slide. Nowadays you'll find some newer version of ASIC as well that you can go and have a look. So you can see that different interfaces are mapped with the ASIC 0, ASIC 1, and the forwarding is happening in the backplane. Now let's go back to our diagram. In the diagram that I'm going to explain you, I'll open in 2 minutes, but before that, you can see that multi-layer switching and the Cisco Express forwarding. So what is the funda here is this, that the route once and switch many. Route once means that your control plane, let's go back to the diagram. So in this diagram, you'll see that your supervisor engine will take decision once. Okay, and rest everything will be handled by the line card. That's why it is telling that route once and switch many. So once supervisor engine will see that where to where the packet will forward, it will go and give that information to the line card, and then next time onwards, line card has to take the decision. So what will happen here, that if you see this particular diagram, you will see when the, so let me highlight here, first time, when you have to go and take the decision first time, then the packet will go to the supervisor. I think this is a supervisor engine which is taking the routing decision. So first packet will go like this, but once, because supervisor engine will build the routing table and it has the ARP table as well, which is what is happening. All the line cards, they are giving the MAC and IP information to the supervisor engine itself. Once they're learning that information, then they are sending this information to the line cards. So they are sending the FiB. FiB is, what is FiB? FiB table, you can see. This is forward information base. It's a database. We'll see that later on. You have all the explanation and all. So you will see different type of terminology. You will see RIB. This is routing information base. Then you will see FIB. Then you will see LFIB. You will see the adjacency table. Adjacency table and all. Everything I'm going to explain. Just wait for some time. These things will come in the upcoming slide. But point here is this, that a routing table, the routers will go and take the decision once, and then they will go and program. They will go and give that information to the line card. Supervisor engine SU will program that to the line card, and then line card will go and do the forwarding, right? Now let's understand this forwarding information base, FIB. So what is FIB? This is something you can see. The new format is called FiB and contains routing or the forwarding. This is something like how you will go to next hop. So routing table is a generic term. There it will give you that this network, I have information to reach to this network, this network, this network, this network. But when it comes to the actual forwarding, then this FIB table will come into the picture. Okay, so basically the routing table is reformatted into a ordered list with the most specific route. So suppose if you have to reach somewhere with /24, with /28, with /31 or 30, how you will reach? So the most specific route to reach somewhere. So you have options. Suppose you have to reach with these routes. Obviously, this is the most specific. You know that it has less number of hosts, right? It has less entries to a scan. So the forwarding decision will happen with 29. If it is not reachable with 29, then it will try 26 and 24 like that. So in the bottom in this line, you will see that it is written that the FIB also contains the next hop address for each entry. When the longest entry match is found in the FIB, the layer 3 next hop address it found. That means that whoever the longest entry route according to that is the FIB table that you have, right? You can go and check these FIB tables as well. I will go and explain you about the SIF as well. What does it mean by SIF? All the time we are seeing Cisco Express forwarding. SIF, I will show you this thing in the diagram. What is SIF and all. I'll explain that, don't worry. So then what is the adjacency table? Adjacency table is something that a router normally maintains a routing table containing layer 3 network and the next hop, and the ARP containing the layer 3 to layer 2. Okay, so this is the routing table, but what is the adjacency table? And then you have the FIB table, that you have the best next hop match, right? Now the portion of FIB is called adjacency table containing of the MAC address of the nodes that you want to reach. So from here, I will go and explain you all the tables, so you will always understand. Let's go here. So we have different type of tables. So first of all, we have RIB table, routing table. What it is doing, that routing table will give you, it will give you the best path to reach to the destination, right? And it is happening at the, in this switch, it is happening in the soup engine. And in the routers, route processor RP, they are taking this decision, right? Any doubt in this?
Okay.
Okay. One sec. I have logged this. And oops. And then just want to change the color. Then what you have? So here they are building the ARP table as well. In the ARP table, what we have? ARP table is IP to MAC table, right? So supervisor engines or routers, they are maintaining these two tables. Now next, what is next? Next you have data plane or line card table or line card forwarding, right? So line card table, line card forwarding. Okay, so in this, what these line cards they are maintaining, right? So line card, they are maintaining the FiB table. What is there in the FiB table? FiB table is where you have best matching next hop entry, right? So if you have /20 /25 /29 etc, it will prefer /29. Now, whenever you are doing the forwarding, you are forwarding in terms of layer 2. That means that if you have reached to the client, obviously you will reach to the client via the MAC address. So that's why we have the adjacency table. What adjacency table is doing? Adjacency table is something IP to next hop MAC table. This is the most what you can see, most specific, or it is the not most, but this is the exact destination where you want to reach, right? And this particular information that we have is in the data plane, and the most specific destination you have with respect to MAC table or MAC address. Okay, so that is the term that if you go and watch this particular recording, you will see that we have discussed so many very important points here, right? And now you will understand that what is routing table, what is ARP table, what is FIB table, what is LFIB. Sometimes it is termed as a LFIB, something label based forwarding information base. If you are learning MPLS or other thing, but here also in this also all the time you have seen this term called CEF, Cisco Express Forwarding. Now Cisco came with this particular idea, and later on it has been copied by the MPLS community, and they have created something called label based forwarding. Later we have this MPLS full cover, so don't worry. Label based forwarding, and later on they came with one idea called LFIB. So instead of creating the routing table based on the IP addresses, why not create the routing table based off labels, the tag value, the numbers like 4, 5, 6, 7, 8, 9, and then the tag will get decapsulated or encapsulated, and then forwarding will happen. It will reduce the overall load from the processor, from the CPU, if we are doing the MPLS forwarding. Same thing Cisco has tried to use within their layer 3 switches, Cisco Express forwarding. And more so over the technology that we have learned here, that RIB and FIB and the routing table, RIB table, ARP table, right? All these things very much they are connected with the Cisco Express forwarding, because by default CEF will be on the switches. If it is not, then you can go and enable it. I think IP route cache is the command to enable the CEF feature within the switch. Okay, you have any questions so far?
Yes, I do.
Yeah, can ask.
So the can you scroll down a little bit? The way you say so you okay, yeah, that's fine. So you have this RIB table.
Yeah,
So you said it will give you the best path to reach the destination, right?
yeah.
Then you have the FiB. This is where you have the best match next up. What's the difference between, because like this FiB and the RIB is almost the same thing, because you said it will give you the best path to reach the destination. This one is where your best path next hop entry. And
Okay,
this one too is IP next up. This one has to do with mark table.
I'll
But
explain.
it's between the FiB and the RIB.
Okay, I'll explain. Okay, so mm, mm, what was the RIB? I'll give you best routing path table, right?
Mhm.
Okay, so let's understand. Okay, let's understand. So suppose you have router 1, router 2, router 1, router 2, router 3, router 4. And let's take example that that you have some PC. So I'll go and draw one LAN switch here. This is LAN switch. And then I will go and draw some PC. Suppose this is PC1, this is PC2, and PC3. And then here you have. Now let's go and connect these. I'll do the connection. Let's do the connection. And then let's go and connect these links. These are the ISP link. Then I will go and connect this. This is my ISP link. And then I will go and connect. All right, so we have the link in between. So routers, what they are doing, they are blocking the broadcast. So that means that if this network is, for example, 10.1.1.0/24, for example, and likewise, I'll go and choose the network. So let me use the small font size. Suppose this is 10.1.1.0/24. Suppose this is 20.1.10/30. Suppose this is point-to-point link. This is 3110/30. This is P2P link. And this is maybe 40.1.10/30. And finally, this particular network is 50.1.1.0/24. Now I want to do the communication in between 10.1.1.100. I want to reach to 50.1.1.100, right? So how it will happen? And suppose here in this region, we are running some sort of OSPF routing protocol. So I'll go and highlight this area. This is running OSPF. So also I'll put on the top, and then the link I want to connect. You can understand this arrangement here. So this is running the OSPF routing. Later on we have section on OSPF and all. Now this particular topology that we have, so what this router will do, suppose this is router number A. This is suppose router number B, this is router number C, and this is router number D. So what these routers will do, tell me what router number A will do.
Um, so it's going to it's traveling from it's going to 5.1.1.0,
Yeah, so whatever we have
right?
studied so far, so router number A will build the ARP table, right? Plus the routing table, right? Now what will happen here is this, that this particular switch that you can see, this line is a switch. This particular switch will go first of all and learn the MAC address, right? So he will know that this is the MAC address I should learn. At the moment you send the frame, it will learn the MAC address. Now what this router will do, this router will go and this router will go and do the ARP, reverse ARP or ARP, and this router having the entry called IP plus MAC. So if IP is 10.1.1.100, it has some MAC as well. For example, AAAA. So it will go and learn, suppose it has some MAC address as well, the hardware table, right? So it will go and learn the MAC as well because it will do the ARP. So router will go and maintain the routing table and the ARP table. At the moment, suppose router has the ARP table. How router will go and maintain the routing table? So router, because we are running OSPF, later on we have this discussion when we'll start the program, this routing protocol, but all these routers, right, all these routers that you are seeing here, these routers, they will go and advertise their network table to all the other routers, right? So advertising the network table, that means how A can reach, to D. How A can reach to D. What is happening here? Okay. How A can reach to B, B, C, C, D, etc. Right? So routers, so in that case, router A will maintain the routing table as well. What router A knows? Router A knows 10 network and 20 network. What type of network they are? They are connected network. They are connected interfaces. They are connected network. What router A don't know? 30, 40, 50. How he will know? From router B. How router B will know? From C. How C will know? From D. So at the moment C will know something, he will advertise to B and D. At the moment B will know something, he will advertise to A and C. They're connected interfaces, right? Via routing advertisements. Correct? So
Mm-hmm.
that means that now router A, if you go and build the routing table, you will see that router A routing table, router A know this is my connected interface, right? Connected network. Then 2110, this is also connected. Then 30, this is, it will get with routing update. Then 40, this it will get with routing update. Then 50, this will get with routing update, right? From some other routers, it got this information. Okay, so now router has the routing table and router has the ARP table. Now since the source is this and destination is this, so the packet, how it will go? So the packet will go hop by hop. So this packet will start from here, right? Let me increase this depth. Let's start from here and let me do this as well. So the packet will originate from here. It will reach here. It will go here. It will go here. It will go here. And then how this D? So D also knows with reverse ARP that what is IP and what is the MAC table. I have to deliver the packet. So packet will get delivered here, right? Oops. So this will be the flow, right? This will be the flow. So the point here is this, that you ask me something, what is the FiB table, RIP table and all those things. So where everything will come into the picture. Now think like this. Whenever there are two types of communication. One is called local communication, one is called global communication. So whenever you are sending the packet from this router to this router, how you will send the packet or receive the packet, until unless you know the physical address. So until unless router A knows the physical address of router B knows the physical address of router A, they will not send and receive the packet. You have to know the next hop address, next hop physical address. That is nothing but the MAC address. Then you can't send or receive the packets. Okay, routing table is a generic term that you know 10 knows that the 20 gateway, 20 knows the 30, 40, etc. So these are the generic table, these are the global table. With this table, suppose 10110 having 250 IP addresses. So network table will reach you to that particular gateway. Think like big apartment, like 10-floor apartment, right? So routers with routing table, you will reach to the gate. But how to go to 101, 102, 103, 201, 202, 203, that will happen with the MAC table. The exact information which flat you have to go. So that is nothing but the FiB table. FiB table is something that is the exactly where you have to go, and inside FiB we have the adjacency table. With help of FiB, this adjacency table will form, that is IP to MAC table. Exact which particular flat you have to go. FiB table maybe get you to the floor where you have 10 flats, which is much more specific than the routing entry. But with the adjacency table, you will get to the flat number.
Mm.
Okay. So that's the importance of ARP, routing table, and everything that we are doing. ARP is something that from where you'll get the MAC address. Again, this with help of ARP and routing table, the actual forwarding will happen, and then you will reach to the actual destination. Otherwise, routers will give you the gateway. Routers where you're defining the gateway. So here you have 250 hosts. How exactly you have to go to 50.1.100? That is done by the adjacency table, IP to next hop table. Okay, and that will form in the data plane of the routers. Routers also having the control plane and the data plane. With help of data plane, it will reach to the this particular location. Okay, so I hope that will answer your question. Otherwise, you please go and watch the recording and you will understand everything.